So hello and welcome, everyone. Thanks so much for joining us today for a webinar on drones in power generation. Today we're going to be hearing about how Exelon Clearsight uses drones to improve safety, reduce downtimes, and save money. Before we get started, I just want to take a moment to acknowledge the difficult times that we're living in. We've been running these webinars for 2 months now, really replacing what had once been planned to be an in-person user conference in Denver for back in March. Of course, we had to cancel due to the pandemic. And we're still going through keynote speakers sharing the content that they'd planned. None of us, of course, anticipated this kind of scenario throughout the whole world, and we know people are suffering. So we just want to acknowledge that before we get started. So thanks everyone for taking the time to be with us today. We're really excited to share information on how drones are being used in power generation. Today we have Chris Place from Exelon Clearsight. He's the Business Development Manager at Exelon. He'll be presenting. I'm your moderator. My name's Zach Dukowitz. I'm the Content Marketing Manager at Flyability. And at the end, we'll also be joined by our Director of Marketing, Marc Gondillon, for a panel discussion with Chris. Marc's worked a lot with our clients in power generation, so he knows a lot about how folks are using drones in power generation as well. So we'll be doing a little bit of a discussion at the end, which will also be included in the Q&A. So we'll be taking questions live from you guys, from the audience, as well as questions that we already have prepared. So just a few housekeeping items here as we're getting started. The biggest one is the first one on this slide, is that we really would like this webinar to be as engaging as possible. Due to the sheer volume of folks who are attending, we can't make everyone's microphones live and have you asking questions live. Unfortunately, it would just be chaotic, but we can certainly field your questions in writing, and we really encourage you to use the questions pane on your dashboard to type in your questions as is shown in this video on the screen. We'll be answering questions in writing live as they come in. We have a team of folks here from Flyability supporting the webinar who will be helping answer questions. And then we'll also be curating your questions for that Q&A and discussion that we have planned for the second half of the webinar. So feel free to start asking questions right away. Don't feel like you need to wait. And we're going to do our best to answer every single question that comes in. So please don't be shy. One other thing, we often get this question: will the webinar be available afterwards? Will there be a recording? The answer is absolutely. We will be sharing the recording via email, so look for that within 24 hours after the webinar ends. And here's our agenda. I'm going to hand things off to Chris here in just a moment. So right now we're in the introduction. That's the first 5 minutes. Chris is going to present for 25 minutes on different use cases, case studies for the use of drones in power generation based on his experiences at Exelon Clearsight. And then we're going to devote the second half of the webinar to the discussion and the Q&A. So again, those questions from you are really important. We really want to be answering any questions that you have and addressing, whatever it is that brought you to the webinar today. We want to make sure that you're getting what you were looking for when you signed up. So I'm really excited to introduce Chris Place. Chris Place is the Business Development Manager at Exelon Clearsight. He's been working to bring in new technologies to Exelon for a while now, and that of course includes drones. Exelon does really important work in power generation, as you probably already know if you're on this webinar. And Chris's work supports bringing new technologies to inspecting critical assets in generation, transmission, and distribution of energy at Exelon Clearsight. So he has a lot of experience in the energy industry, and specifically in how drones are being used in the industry to revolutionize things, improve processes. So I'm really excited to have him here, and without further ado, I'm going to hand things over to him. So give me just one moment, Chris. I'm going to make you presenter.
Thank you so much, Zach. Can you hear me okay?
Yes, sir. Yeah, I can.
All right. Appreciate the intro. Thank you. Showing my screen now. Let me know when you can see it.
Looking good, Chris.
Okay, thanks so much. And good morning or afternoon, everyone, depending on where you're dialing in from. Today, I'll be talking about our company and talking about some of the use cases that we're most proud of and our experiences providing remote inspections in power generation. So before I begin with our case studies, I'll give some quick background information about our company. We are a wholly owned subsidiary of Exelon Corporation, which is the leading energy provider in the United States, employing about 33,000 people. So our team within Exelon started in 2017 when they launched us as a startup company aimed at leveraging innovative technologies to provide critical asset inspections to the energy sector, both commercial and also within Exelon as well. Our focus areas initially and still are providing inspections to power generation facilities, as well as to transmission and distribution systems. So we've served many commercial clients across the United States in power generation and also some municipal safety applications, emergency response, and some law enforcement applications as well. So far, we've seen that our services aren't just providing value to customers in terms of providing insights, they're also improving safety for our customers, which in the energy industry, we've seen many challenges just with entering high risk zones and just improving safety altogether. So also, we have transformed the way our data is analyzed and transitioned to our customers. We've developed two proprietary software tools, one for analyzing data. Our team has subject matter experts who are using our Workbench tool to analyze data and then review it and provide it to our customers through our proprietary customer portal. That customer portal displays data in a nice visualization so that our customers can immerse themselves and interact with the data set in a better way than just like a document style report that is non-interactive. So now that I've given you a broad understanding of our company, I'll move into a narrower focus on our power generation core services. So with thousands of cooling towers at power stations across the US, we've been very active inspecting components such as canopies, fill structure, risers, aviation lighting on the tops of the towers, inspecting the climbing safety equipment up the sides of the towers, welds, dampers, silencers, and many more. And then ASME Section 11 IWL concrete inspections have been a high value item for our customers. We're seeing that there's a rise in demand for visual assessment of concrete to meet ASME codes. And in the nuclear industry, it's very important to meet these codes to ensure that your concrete is up to spec. And in our industry, we have concrete containment structures that house our reactor systems and prevent them from exposing radiation to the public and protect the same reactor system from the environment and other things. So historically, inspecting these concrete containment domes has been very cumbersome and dangerous. Oftentimes, personnel are rappelling off the sides of these domes or using binoculars or telescopes to perform the work, whereas we're actually using drones with high resolution optics to gather much better data in a more efficient and safe manner. So our subject matter experts or our customers can sit behind the desk and review the data coming in and not have to rappel off the sides of the towers, which may sound fun, but it's not the best way to do the job. We're seeing a rise in demand for our submersible and inspections of dams, being that diving is such a costly and unsafe activity. It's really best to just offset diving altogether and use submersibles instead. This year in particular, we're seeing an increased demand for inspections of service water systems at nuclear facilities, basins, tanks, and fiberglass piping inspections. So I see here listed confined space confined space inspections, really high temperature zones, high radiation areas, confined spaces. We can just phrase it all as high risk zones. It's best to send our robotics in and collect the same data that ordinarily personnel would have to enter. So we're offsetting a lot of risk by using robotics. In addition to having one of the largest inventories of flyability drones in the world, we are also very heavy users of flyability equipment. So we are an authorized reseller of flyability equipment. We can provide specialized training and also maintenance to our North American clients. We have 2 research and development projects open, which are exploring automated robotic systems for use inside and outside of power stations. Focus areas are exploring ways to automate remote monitoring of radiation, dose mapping, and also security and maintenance planning purposes around the sites. Now, condenser inspections are a real passion project of mine. I've been developing our services for condensers since day one of our company starting, and they're one of our core services now. We've performed dozens of these inspections for commercial clients and Exelon clients to date, and we continue to develop our technical capabilities for this inspection. We're actually working on an interface where 3D modeling and photogrammetric capabilities are able to be used within our customer portal so that our customers can immerse themselves in a visual reconstruction of their plant environment and condensers and view defects and their locations without actually having to take on risk or dose exposure by going into the plants. And lastly, we have performed a number of heat recovery steam generating station and coal plant inspections, primarily focusing on the turbine area, the gas path, tube bundles, structural steel inspections, as well as burner components. So next I'll talk about some of our case studies that we've picked to highlight. So for this first case study, I'd like to first give an understanding of what the condenser space does, in case you're not familiar. The purpose of the condenser is to recover and condense steam that has already been used to spin the turbine, and then it's recirculated back into the plant system to be reused. So during this project, we were tasked with entering the condenser steam space to identify steam erosion on steam shielding. This steam shielding is used to protect seals throughout the condenser. In this particular steam shield, it's protecting the dog bones shield, which creates a vacuum seal in the condenser. So damage to the shielding could result to damage to the seal itself, resulting in reduced reliability for the plant. So during an 8-hour shift, we were able to inspect 3 condenser units and gather imagery and localize issues and anomalies into a report to give the site's engineers. We used the Flyability Elios 2, which enabled us to get very high resolution, close imagery of steam impingement zones. Normally, to gather these same insights, the site would have needed to spend about 200 man-hours to erect scaffolding, and that would have cost approximately 4 to 5 days just to build the scaffold. So the cost savings are tremendous in this inspection. And also, if you're able to see on the image here, you have a measurement. This measurement was conducted using in-flight data collected with the Elios 2. So we were able to cut the inspection time down to 8 hours instead of 5 days. So being that personnel were not spending time inside the condenser units for 4 to 5 days, we reduced the amount of dose exposure to those personnel as well. So we used 2 people to perform this work instead of 8 to perform the work if not for our drones. So cumulatively, our 2 personnel received 7 millirem of dose exposure, whereas 8 people would have received 3 rem of dose exposure if not for us. So to clarify, 1 rem is 1,000 millirem of dose exposure. So pretty significant there. Next, I'll talk about our online valve assessment. During this mission, our customer required us to perform an inspection of suspected heat leaking valves, and we were tasked with doing this inspection while the plant was still online. We used the infrared camera on the Elios 2 to identify 2 valves that were leaking from their installation, and we provided this information to the site engineers so that they can make critical decisions for next maintenance actions. We saved 250 millirem of dose during this mission, which is significant, and we completed it within 2 hours, whereas it would have taken 2 days for the plant to derate or depower to a point where the temperature of that room was sufficient for personnel to enter. Next case study. I think I skipped ahead. Sorry about that. Okay, so during this mission, our customer was at a critical decision point. They knew that there was a steam leak inside their condenser bay, and maintenance was trying to determine what that steam leak was impinging on. So if it was impinging on a critical structure, the plant would have needed to derate to 25% power to actually send a person in to rectify the issue. But if it was not impinging on a critical component, they would be able to stay online for an additional 2 months until their scheduled refueling outage and then fix the issue at that time. So we were able to fly the Helios 2 very close to the steam plume, as you can see here, and determine that it was not impinging on a critical component. It was impinging on a non-critical steel hanger and enabled the plant to stay online. So it's estimated that a plant loses $1 million per day of lost revenue due to being offline. So if they had to derate to 25% power to access the area, they would be losing approximately 750,000 per day. So we were actually able to go in and identify this leak within 4 minutes of flight, and it would have taken approximately 8 hours of derated time for the plant to actually access this via personnel. Next, we were able to attach a dosimeter integrated into our drone to record dose rates at the steam plume of 2.2 rem per hour, which is very, very high. So we were able to gather quite a lot of data for this site during this inspection. Next, make sure we're doing okay on time here. Okay. Next, I'll talk about our reactor cavity liner inspection. We had a two-faceted objective during this mission. One was to inspect all of the weld seams inside the reactor cavity once it was flooded down, looking for small pinhole leaks or large degradation. The secondary objective was to settle a bet between site engineering and maintenance, who knew of the leaks but were wondering if it was a series of large identifiable cracks or just very many pinhole leaks. So during the mission, we spent 6 hours identifying various pinhole leaks covering the entire liner, whereas it would have taken 2 days for about 6 personnel to lower off the side of the cavity with fall restraint hardware and scaffolding to actually perform this inspection. So pretty significant time savings here. And also, you can't see in the image here, but down below in the liner, there was a crew of reactor service personnel actually working on the reactor head. If scaffolding was needed and people were lowering off the sides, those reactor services personnel would not be able to be in that environment. So we were able to conduct our inspection without interfering with their processes. So we were actually able to complete the scope of work within the outage window, whereas without our services, they would have needed to extend the outage window by 2 days, losing approximately $2 million. During this next mission, we were actually dispatched on a Friday evening. We received an emergent request from a site in the central United States who went into a forced outage because of a blown expansion joint. They didn't know the location of the blowout, and they were planning to spend approximately 2 days to upscaffold that condenser, go in, identify the blown expansion joint, and then replace it. But actually, we were able to book a flight on Friday, arrive to start the inspection on Saturday morning. And we went in and performed the inspection in and out of containment within 2 hours. And then within that same working shift, maintenance was able to go in, extract the blown expansion joint, and replace it. And in unison, they sent the expansion joint to our facility for our engineers to perform a failure analysis and get a report for the customer. So really the response time is one of the biggest benefits here. But also, if you think about the reduction of industrial safety risk and the 250 millirem dose spared, it's a pretty tremendous inspection. This is actually one of our more recent inspections. We were called on a weekend because of one of our customers in Texas had an issue identified during a scheduled maintenance outage. We were tasked with coming in to perform an emergent inspection inside of the boiler to identify signs of tube swelling or tube out of rounding, as they put it, and also ruptures. So instead of spending 3 to 4 days to upscaffold the furnace, and then identify these signs. We were actually able to do the entire inspection in 8 hours with an Helios 2. As you can see, gathering incredibly high resolution imagery of burners, the tubes themselves, headers, and various other components. And one qualitative benefit of this inspection, we actually did this during the COVID pandemic. So by reducing the amount of personnel from 8 between scaffolders and engineers down to 2 for our team, we're able to reduce the amount of personnel exposed to each other and employ best practices for social distancing, being that we were operating the drone remotely. So, we've done various HRSG or heat recovery steam generating station inspections, but this one's noteworthy for us because we did the entire system front to back. So this HRSG unit was in California. We were tasked with collection of data all throughout the gas path, the economizer section, the basements, and the stacks as well. And we were tasked with looking at support structures, the injection nozzles, and also the longitudinal and circumferential welds around the stack. We identified some issues in the damper section, which would have been very, very difficult to access if not for the drone. So all in all, we completed this inspection of Unit 1 in the foreground of this picture within 12 hours instead of 5 days to do it without our services. Next is our ECT pool foreign material retrieval inspection. I say inspection because at the beginning, our customer wanted us to inspect the structural supports and various components of the pump suction strainer in this environment. But in doing so, we identified a number of foreign material debris that needed to be extracted. So instead of sending divers in, we were actually able to use the claw on our submersible to extract 10 foreign objects. And these foreign objects were posing a risk to the reliability of the plant. In an instance where one of those pieces of debris got sucked into the pump, that could lead to serious economic or safety risk and other implications. So here's another submersible use case. In Washington State, we responded to a customer need where we inspected a 600,000 gallon municipal water tank. Purpose of the inspection was to look at structural components, piping, and satisfy fire safety requirements. We did all of this, and we're also able to determine silt depth at the bottom of the tank by using the claw on our ROV. So really, it was a net neutral cost for divers, but it did save time. It took us only 3 hours to do the entire tank, where it would have taken about 6 to 8 hours to do with a team of divers. We also used 4 less personnel, being that we were a 2-man job for this mission. Divers often require other attendants and standby divers for safety. So we also performed an underwater depth survey after a desilting operation at one of our facilities. We used 2 tools for this job. We used a drone to gather aerial imagery of the desilting operation, and also a submersible to gather silt depths and other data underwater in the channel. So this was a service that we were able to insource within Exelon. We're an in-house provider to Exelon, whereas an outside vendor would have been very costly to hire for this geologic survey. Very proud of this one. One of our customers in the Northeast spent about 6 months searching for the source of a leak inside of their loop room at their nuclear facility. They had expended a tremendous amount of radiation dose trying to find this, and we're on the verge of actually going into an outage to send people in to identify the source. But we actually got a call, and we deployed a crawler into this high rad area, and in 54 seconds we located this leak. So pretty tremendous cost savings attributed to the site avoiding a down power altogether. And also we saved significant dose by not sending people in for this. All right, I believe this is our last case study here. So our customer's need was to inspect 100% of their storm drain system beneath their nuclear plant. And this was to satisfy their nuclear carriers, insurance carriers requirements. the site had gone out to a vendor, and the vendor quoted them $750,000 to do an inspection of their system over 3 months. Well, our customer is very fortunate they found us because we quoted them $30,000 and completed the inspections within 5 days. Now that vendor was proposing to do excavation to remove outfalls and drain covers and then send people in under confined space permits to perform this inspection. Whereas we were able to just operate our crawlers and not send people in or do any excavation altogether. So tremendous benefits because of the cost avoidance to the site and also the time savings. 3 months of excavators working outside your site on storm drains as opposed to 5 days. To me, the choice is obvious there. So in summary, we've compared our means versus traditional means of inspecting, and what we're seeing is that traditional means often expose personnel, and often an unnecessary amount of personnel, to radiological, to temperature, and other risks that are just unnecessary. So we're reducing or eliminating dose exposure altogether, and oftentimes offsetting scaffold builds entirely. So also, we're gathering a bit better of a data set in most inspections because our equipment is using high resolution optics, thermography, LiDAR, other data sets in a recordable fashion, whereas oftentimes, historically, people have inspected on scaffolding and just put their eyes on an issue, but not actually documented or recorded those issues. So for archiving purposes, our data sets are a bit more effective. Also, conventional inspections, sending subject matter experts and engineers on top of scaffolding puts them at risk, whereas now we can just collect the data, hand it to them, and then they can stay behind a desk out of harm's way to do the inspection. In most cases, traditional inspections require a derate or a depower of a power generation facility to make it safe for performing the work, whereas we're able to perform work at full power and also while the plant is offline. So at this time, I think we could turn it back over to the Flyability team. Here is my information. My number and email is here. Feel free to reach out at any time. And I think during this panel discussion, we can have some healthy conversation about how we can fit together and maybe can uncover some answers for you.
Excellent. Thanks so very much, Chris. Let me take back over presenter role and share my screen again. Okay, great. So yeah, Chris, I just want to say thanks again for making things concrete. It seems like we're often hearing about how great drones are and how robots in general are going to change things, but it seems to often be abstract. So I appreciate you talking us through all those specific instances where robotics have added value, saved money, kept people from harm's way, reduced exposure to radiation. So it's awesome. Thank you very much.
Thank you.
Yeah, we're going to get to a Q&A here in just a moment. Before we do so, I just want everyone to know that this webinar is part of a series. I mentioned that at the beginning of the webinar. We've done a bunch of webinars already. We started in April. Again, these webinars, the content came from the keynotes that were planned for our in-person conference that was going to be in March in Denver in our first US office. Of course, had to cancel due to the pandemic, but we've gone online as many other folks have and started doing webinars. So here are some of the webinars we've already done. As you can see, there's quite a few. There are recordings available if any of these topics are of interest. And you can find out, this list lives on our website. So if the slide goes away, don't worry, you can go to our website and see what webinars may have already been done that you might be interested in. We also have 2 webinars upcoming. Next week, we're going to be talking about how to perform safer confined spaces inspections using drones. And that talk will feature Alex Meldum, who's our VP of Sales. Alex works with clients all over the globe in all kinds of applications. So he'll be talking to making confined spaces inspections safer using the Helios 2. I'll be hosting that webinar as well, so I'll be on for that one. And then we have another industry-specific webinar coming up in early June on using drones in the cement industry. We're really excited about that one as well. So please join us for any of these upcoming webinars, and please visit the webinar page, the links here on the bottom of the screen, if you're interested in any of those past recordings. Okay, so all that being said, we're going to go back to the Q&A and dive into a discussion with Chris, and Mark's also going to be joining us now, Mark Gandillon, our head of marketing. And again, this slide is going to be up throughout this conversation. If you want to reach out to any of us at Flyability, everyone's contact information is up there. And oh, I apologize. This is actually the wrong information. So maybe Chris, if you could put your slide back up that has your email on it instead of this one. That's my oversight, and I apologize for not having
No
your
problem.
email here. Can I hand things back over to you, and you'll just share the slide that you had up last?
Sure.
Thanks so much.
Can you see that?
Perfect.
Perfect. Thanks, Chris. I appreciate your support on the fly.
Sure.
Okay, so I'm actually going to start by, we're going to hand things over to Mark. I think he has a question for you to kick off this Q&A.
Yeah, I do have a question, and especially to give you know, the audience some overview of how did that get started, because I think we've been working together now for 2 to 3 years, and you probably had you know, you went a long way until you can actually perform all those use cases that you presented. So I'm wondering if you could tell us, you know, a little bit your story, your journey until there. You know, what were your objective at the beginning? How did you basically say, oh, you know what, we're going to apply this technology because we see a potential for saving?
Sure.
Be really interested about
Absolutely.
that.
Yeah, so I started with Exelon in 2015, started in a very basic data entry position, and I started within a very entrepreneurial department within Exelon. It's called Exelon Power Labs, performs calibrations and engineering assessments for hundreds of commercial clients and for all of Exelon. So this was the first, really the first entrepreneurial segment of Exelon that was actually doing services for not only our company, but also externally outside of our company. So I think I started at a reasonable place within the company to kind of incubate entrepreneurial projects. So I transitioned into a sales role for our engineering services, and you know, during my time seeing a lot of the equipment being used across Exelon, like submersibles, crawlers, and drones, I also had the opportunity to talk to people about the cost savings experienced using these robotics. So in doing so, I think you know, a few of us had some early conversations about how robotics would be a fantastic business to get into. But in unison, Exelon leadership at leadership level, they have a department which incubates startup projects. They were talking about ways that they can open new channels to bring revenue into our company and leverage technology to perform new means of inspections. So you kind of put those two ideas together, and we were chosen as the firm to lead this company and develop it from the ground up. So started as just 4 of us, kind of huddled around a desk clump, talking after our regular job was done for the day about how we could turn this into a business. And fortunately, we have 3 great founders on our team who took this vision and turned it into just a fantastic team to work for. I think we're around 56 personnel now on our team, and you know, it continues to grow very quickly. And I value our team's philosophy, and it's that you don't go out and overpromise doing things. You try to get as much work experience as possible into your company, and then from there you can innovate and increase the efficiency of your processes. So that's been a real pleasure. Thanks for asking.
Hey, thanks so much, Chris. I have a question about the use of robotics and drones specifically in power generation. Are there any challenges that you've encountered that you feel like are specific to power generation as an industry in implementing robotics for inspection purposes? And I know, of course, you know, I'm not sure if you have experiences in other industries where robotics are being used, like, you know, oil and gas comes to mind. But you know, even at a top level, if you could speak to specific challenges, we'd be curious to hear about that.
Sure. I'll start by saying there's a very transcendent challenge that's agnostic of the industry, and that's reluctance to adopt new technology. I think historically, the power generation industry has operated in its own ways and according to its own procedures, and they've done a very good job with those, but getting new technologies to integrate is often a challenge, which is a challenge that I see as an opportunity because, people in my role try to get new business, and it's just a matter of having a couple use cases to point to show people the value of integrating innovation. So that's one. And I think some other challenges that are more specific would be, when you're operating in high rad areas, sometimes your equipment can get trapped. It can go into a contaminated zone and get contaminated itself, and it can never come back out. That very seldomly happens, but of course that risk does exist. Beyond that, I can't think of any specific challenges.
Thanks so much. Mark, do you have a question? Or I have some questions too, but I want to be fair. So if you have some, please hop in.
Yes, I think you touched a point that is quite interesting, where a lot of people are asking themselves questions about that. So, what about radiations? How does the equipment handle that? The equipment that you use, and also one point that you touched. So, have you found a way to organize yourself so that you can transfer your equipment from one place to another? I mean, one reactor to another, or one plant to another. I think those are, burning questions in the audience.
Sure. So I can speak to the tolerance of some of our equipment. Some of the crawlers that we're using are moderately radiation tolerant, but you start to see issues with the cameras in some instances. But robotics are generally more tolerant of radiation than you think. And for example, I can say that during some of our early conversations with flyability, we were asked to conduct a radiation tolerance test with the Helios 1. So we exposed the E1 to a radioactive source and ramped up the radiation to 800 rem per hour as the dose rate, which is really more than you should ever see at a nuclear facility. And the Helios performed just fine. I mean, we started to see a little bit of pixelation with the thermal camera, but once the dose rates ramped back down, we were fine. So, and I think flyability accidentally made a rad hardened device. I don't think that it was flyability's intent to do that. So that was pretty cool. And then the second part of the question, as an Exelon company, we have the gift of access to radioactive licenses that enable us to transport equipment from site to site in a lot of instances. But in some cases, it just makes sense to just leave the equipment on the dirty side. So on 2 occasions, we performed inspections for customers, which kind of contaminated the equipment, or crapped up, as we call it. And it's now certified as a dirty tool, and it doesn't leave containment. So, that's valuable to the customer, because then they can just pick it up off the shelf and use it once it's already contaminated and not have to worry about recontaminating it.
All right, thanks for that.
A quick question, Chris, about high temperatures, operating at high temperatures. This is from Quentin, who's joining us today. Quentin writes, thanks for sharing all these case studies, Chris. We know what the suggested temperature conditions are for the Helios. Can you tell us, if you happen to know, what the maximum temperatures are that you've operated in, and did you do anything to mitigate operations in higher temperatures? And I imagine you could speak to other scenarios where you've used robotics, not just the Helios, in high temperatures.
Sure. So I can say that loop room inspection was about 155 degrees Fahrenheit. That we used a crawler, and the crawler operated fine. And then I think I can say this, but I have to disclaim that we don't authorize or recommend flying Helios equipment to this temperature that we did, but we flew an Helios at 165 degrees Fahrenheit, well above the manufacturer rated tolerance. And we did so and had no issues. So again, I don't condone doing that, but it worked fine. And of course, there are risk mitigation strategies you always have to consider. especially when you're putting your equipment at risk inside a nuclear plant. So in that particular mission, we had a tether on our Ilios, knowing that full well it could go down at any time. And if that drone were to have gone down in that foreign material exclusion zone, that could have caused issues to the plant. So we were able to use a tether to reel it back in and keep it out of critical plant systems.
Awesome. Thanks, Chris.
Yeah, I see an interesting question because you mentioned you did some tests where you mounted a radiation monitor on the Ilios and to get the info on the steam. So how did you do that? So do you just duct tape something on top, and how did you record the data? How did you extracted the data about the steam?
Well, that's a great question, and I really wish I could answer you now, but I think we should save that one for more of a one-on-one. Being that that's a development product, I don't know what I am and am not allowed to say on that one. So we should follow up with that question. Thank you.
All right. So I think the person in the audience who asked you, so you have an invitation to send an email to Chris.
More than fair.
Thank you.
Chris, we have a question from James. You mentioned performing work during the pandemic, and of course that's top of mind for all of us right now. Can you speak to any benefits you see of using drones for inspections in power generation in regards to supporting social distancing efforts? Have you seen an uptick? Have you seen extra value? Anything you can speak to about that topic?
We absolutely have. On multiple occasions, even in the last few weeks, we've been in touch with customers who are working from home. A lot of the people who come to us with these inspection ideas are program owners, like someone who owns the program of inspecting the concrete at the facility or owns the service water system. They'll reach out to us and say, hey, we're calling you because we need the least amount of people possible to do this job, and we need the results quickly. So there has been an uptick in our business, I would say due in some small part to the pandemic. And then, with a few of the sites, with one in particular, it's gotten some bad press lately for requiring thousands of workers, about 1,200 workers to come support a maintenance outage. Well, those personnel are not necessarily avoiding each other. They have to work closely. So it's especially important in these times to try as hard as you can to reduce personnel and keep people away from each other. So we were able to support a site that got some bad press recently and reduce the amount of personnel from 8 to 2 required for an inspection. And like I said earlier, remote inspections, you can be standing far away, as far away from each other as possible and still be gathering the same results.
That's great. Really appreciate that, Chris. And I mean, that lines up with what I've been hearing too, but it's always great to hear from someone who's actually in the field, right? Who's actually doing work. Thanks so much.
Sure.
And maybe a question about return on investment, because I think this is always a question when you're starting with drones and you're asking yourself all those questions, because equipment is expensive. That's a fact, and the startup cost is always expensive, because you got to get trained, you got to find your case studies and where you're gonna apply the technology. So how did you state your initial case and find your ROI? Because it seems that a lot of maintenance planner they're saying that the initial cost is too high, and they fail to see the benefit on the long term. So what's your experience on that?
Our experience has been that every time we use one of these new technologies, we're seeing tremendous cost savings that usually can easily give you the business case behind supporting a purchase of that equipment. For instance, when we first discovered the Ilios 1, I think we bought maybe 3 or so and then discovered its value and quickly went out and bought 17 more. So it's just a matter of applying them and trying to look for your company's operating costs, areas where there's inflated costs and also where safety isn't really in a place where it should be. So using these robotics in the right applications is key. I wish I had a better answer for you. Honestly, ROI is one of the most elusive topics you could ever imagine, just because everything's so different. It differs industry to industry. At Exelon, it varies station to station. It's just it's a very subjective question, but we're always seeing ROI. The cost of the Helios being 33,000 for the E2, cheaper for the E1. Sometimes we're seeing 300,000 to $1 million saved for every inspection. So you don't want to be short-sighted and think about the sticker shock. 33,000 is not really that much when you think about up scaffolding a single furnace in a boiler. That's going to take you 20 to 50,000 in some cases.
Thanks so much. And
All right,
you
yeah.
had some, yeah, sorry, Mark.
No, go ahead.
Yeah, Chris, you had some really great numbers attached to ROI too in your case studies, and some of those are really striking. Even to me, I've seen a lot of these stories and these case studies, but the amount of savings and the amount of downtimes, the reduction of downtimes, or the higher efficiency for turnarounds, it's pretty incredible. So yeah, thank you. We have a question from Rian. The question is about what you were speaking about, concrete inspections. And the question is, were you generally looking for cracks and fractures? Were you looking for something specific? And how did the Helios help you in that inspection?
So concrete inspections are usually conducted with larger airframes with super high resolution optics to identify gross degradation, cracking, large holes or damage. And then the Helios 2 is a follow-up tool to gather a closer inspection. So, pitting and tiny fractures are really hard to identify with a large drone with a far standoff. So, it's more than just cracking, but it also depends on what type of code you're trying to satisfy. If you're talking about the ASME Section 11 code that I mentioned, there are very specific visual acuity requirements because cracks of a certain width matter a lot to that particular code. So you have to ensure that your camera can detect issues. If you're familiar with the concept of visual acuity, it's like when you go to the eye doctor and look at the tiny characters on the wall. If your camera is required to see VT1 level acuity, your camera has to be able to spot a defect that's 2 or so millimeters tall. So depends on the inspection, but of course, usually you want to bring out multiple tools for the job.
Got it.
Hope that answers your question.
Yeah, it does. And what I'm hearing is that the Helios 2 is what you use for the finer detail work.
Yes, that's correct. And then like the shotgun approach of using a very large airframe, high resolution camera from a far standoff, you're able to get much more coverage, approximately 5 or so feet in width for your field of view. Whereas the Helios 2, you're getting maybe 12 inches or 6 inches of view because you're much closer in proximity to the concrete.
Makes a ton of sense. Thanks, Chris.
We have another question from Antonio. He's asking you if magnetic fields and generator, do they have an influence on the drone? Because that's something that's often the case. If you have drones that are flying and relying on a magnetic compass. So is that something you enter in with the Helios 2?
Not with the Helios 2. We actually haven't noticed that at all. Maybe we're just lucky. I know with other airframes, it can be an obstacle to overcome. It really hasn't been all that problematic for us. More the issue lies in wind speed or, at nuclear facilities, you have to unlock drones to use them at the nuclear facilities. Yeah, but really not too much trouble with magnetic fields. I think EMF is more of a concern. A lot of plants that we're inspecting are energized, so challenges due to flying your energized assets is, again, more of a concern than magnetic fields.
All right.
Thanks, Chris. We've talked a fair amount about inspections at nuclear power plants, or you have today. And we have a question from Andrew about nuclear plants. The question is, what are some of the higher perceived risks that need to be considered when conducting inspections or using drones specifically at nuclear plants?
Higher perceived risks. I guess really risk is risk, no matter where you are. Even something so much as a hand injury or slips, trips, and falls, they're taken very, very serious at nuclear stations just because there's a lot of bad press associated whenever something goes wrong. So I don't know that I can answer that one as specifically as I'd like to, but I think as it pertains to the nuclear industry in specific, there's always the risk of getting exposed to radiation dose if you're in a high rad area. So I'm not sure if I could be of any help for that question. Temperature fatigue, that's another one that's prevalent in our industry as well as many others.
Yeah, and that's
Maybe
definitely helpful. Also, just speaking to the PR concern, right? That you're even maybe more scrutinized if something goes wrong. So yeah, that's helpful. Thanks, Chris.
Yeah, you know what? I actually thought of one more that's not a risk to personnel safety. It's more a risk to data, and it's cybersecurity. Using robotics in any application tends to have the risk that maybe some data could be compromised, but the nature of our data in the nuclear industry is it's very confidential and sensitive. So we have to ensure that when we're operating robotics, namely drones, we have to ensure that we're meeting the export control compliant data requirements and not sending our data of critical plant systems up to the cloud to be transmitted wherever. So that's a huge thing for us, and we work very, very hard to make sure we're compliant and make sure our customers are protected with their data.
Thanks, Chris.
all right. Yeah, maybe a question. Just back to some of the use case you mentioned where you're inspecting concrete and according to the ASME Section 11 code. Actually, are you able to achieve formal inspection with the LUS2? Is this something that you can actually get a certified inspector to look at the result and put his stamp next to it? Is that something you've achieved yet?
So yes, we have gone out and performed missions for ANII certified inspectors to give them the data that they need. I mean, we're doing a non-NDE, non-destructive type of examination of the concrete, but we're satisfying the visual portion of that just as the inspection was without the drone. Conventionally, inspectors who are certified have to use binoculars to gather insights. We're really just presenting them the data without them being up against the concrete themselves. So, a typical process would be us collecting the data, having a large screen television so they can review the data in live time. But in other instances, they just want the data and be able to sift through on their own from behind the desk later.
All right.
Thanks so much, Chris. We have a few LEOS2 specific questions, so I'm just they're sort of brief, so I'll just do these back to back real quick. We have a question from Jim just asking how many LEOSs do you typically use on a mission? And do you bring extras as a backup, and if so, how many?
We do. We've brought as many as 3 out on a mission, but typically we'll bring 1 or 2 depending on the nature of the work. Yeah, and sometimes we'll bring an E2 and then an E1 for a secondary component within that work scope, because the E2 can't roll, the ELIOS 1 can roll. So sometimes we need the ability to roll during the inspection.
Awesome. And then a follow-up question about the E2 specifically. Paul is asking if the E2 is susceptible to updrafts in cooling towers when talking about stability and position holding.
Yes, every drone is susceptible to updrafts or wind current, but fortunately, if you fly close to objects, the ELIOS 2 can grip on with its sensors and perform its own form of stability. So if you're familiar with drones flying in attitude mode, they're basically just subject to whatever wind flow or disturbance is present in the air. The Helios 2 is no different. If you're flying the E2 in ADI mode, or if the sensors aren't close enough to an object for them to use for stabilization, then yes, you are subject to drift, but it has not been a problem at all for us. It's actually really wind tolerant. We flew up in the state of Maine in the Northeast, and they get some crazy winds on the coast, and we just we did a tactical inspection for a police force, and the winds were crazy that day, and it did just fine.
Cool. Hey, Mark, I don't want to hijack things, but I'm so curious about that tactical inspection Chris just mentioned. Can we hear about that? That sounds pretty interesting. I know it's a little off topic, but I would love to
It's
hear about
fine.
it.
Yeah, certain departments up there were really interested in drone technology, and seeing how they could apply them in tactical scenarios like, active shooter response and such. So I went up and visited, and we were simply going to fly it inside their barracks and from within their armored vehicle just to see how the signal did. It performed tremendously well, with no issues to signal. And then one of them joked that they should shoot a window out in their tactical range and just see if the Helios could smash through the window and go in. And I thought they were kidding, but next thing I know, he has a baton gun with a 40 millimeter baton, and he shot the window out. We smashed the Helios 2 right through the opening, which was this big, and actually went in and identified a perpetrator, that a mock kind of actor. So it was really interesting.
Wow. I'm glad I asked.
We
That's
just
cool.
did, actually, that was on Tuesday of this week, we did another one, and it was a similar kind of situation with a local department, I'll say.
Cool. Okay.
Yeah,
Thank you.
maybe back to the inspection business.
Sorry.
Just an outlook on the future. I think through. I mean, it's two. These are two questions, but is the reduction in inspection cost, also time and especially radiation dose exposure equates to more inspection at Exelon. And do you foresee it's progressing in the future?
You cut out for a second. I heard you say more inspection, and then I lost you.
Yes,
Sorry.
I mean, yeah. So let me repeat the question. So is all these results reducing inspection cost, inspection time, and also the amount of dose exposure that you're saving, does it equate to more frequent inspections at Exelon?
Absolutely. Yeah. So pretty much when a plant gets a taste of what we can do for them, they always have us back. And oftentimes they're having us back while the plant is still online, because you're able to give them data that they usually have to wait till an outage to get. So yes, we're coming back on a much more frequent basis. We have plants that we visit 4 to 6 times per year. Yeah, and also just people are now becoming more aware of the benefits of using this technology. So I think the biggest barrier to us spreading this is just the lack of awareness that it exists.
Yeah. Yeah, no, definitely. And just curious to see, how do you see that evolving in the future? What are the next step for you guys? Is it, I don't know, you mentioned, radiation mapping, you mentioned automation. I didn't hear you talk about 3D modeling and how does that would apply to you guys, but how do you foresee this inspection evolving at Exelon?
So you mentioned 3D modeling. I did earlier in my slides. That is one of the next development pieces for us. The end goal for us is to keep people out of risk zones, send less people in, and gather the same, if not better, data than ever before. And beyond that, we just want to continue to get better and better at doing so and improve our own efficiencies. But really, it's all about just connecting the right people to the right data. So 3D modeling, for example, instead of an engineer going in and banging their knuckles inside a condenser, we want to hand them a 3D model of their condenser so they can zoom in and see localized issues.
All right. Yeah, that's definitely what we see as well. We run a few webinars on 3D modeling, and it seems that it's still an unexplored area that we see a lot of results already, but there's a ton of things to do there. So I'm glad to hear that.
Sure. Yeah, that's an immediate focus area for us. I mean, artificial intelligence is another thing that eventually our industry will get to, but I think for now, our focus is on just getting as much data through our systems as possible. Machine learning is in the future, for sure. We're all thinking about it.
All right.
Thanks so much, Chris. So we're a little over the half hour right now. I think we're going to go ahead and wrap things up. Unless Mark, do you have any burning questions you want to ask Chris before we close things out for today?
It's not a question directly for Chris, but there's a question in the audience about the size of the Helios 2. Well, actually, maybe Chris, you can answer that. It was in relation to the size of the condenser bay, the condenser unit that you inspected. So is it what's the size relationship between the two?
Most manway accesses are 24 to 36 inches in diameter. The Helios 2 is 15.75 inches, if I'm correct. 400 centimeters, actually, to be exact. So we generally have significant clearance. We've only ever gotten one stuck, and we were able to retrieve it with a pole, but that was in a very, very small environment. It was about 14.5 inches across. That was not in a nuclear plant.
And I'm curious, in those scenarios, 10 years ago, how would you collect visual data on something like that?
A lot of scaffolding and a lot of headache and a lot of temperature fatigue and dose exposure and money spent on scaffolding.
And downtimes, and yeah, that's fascinating. I think that's going to be it for today. Well, one last question for you, Chris. Can you speak to, we've talked, you brought up security and nuclear inspections and how that's sort of a unique consideration there. Can you speak to the IT security of the Helios 2 for nuclear sites?
Oh yeah, so the Helios 2 is fantastic to satisfy the concerns of cybersecurity and IT on site because it's able to be air gapped so well. You take the Helios 2 and you fly with a tablet in airplane mode, and all your data is stored locally on the machine. It's not capable of transmitting info to the cloud or anything, much like other manufacturers. So for us, the process is very simple. You have your data on the drone. You make sure you're putting it onto the proper machine and you're not exposing it to the network and also sensitive plant data. And then you can just scrub the data right off the drone very easily before you leave site with it.
Awesome. Thank you. Chris, we just want to thank you so very much. I also want to thank everyone who's attended today for giving us your time. I think I learned a lot from you, Chris. I'm sure other folks that were on learned a lot too. So we really appreciate you sharing your experiences and sharing your insights and your time. So thanks again. And yeah, we had fun, I'll say.
Thank you so much. Really appreciate the Flyability team. This has been excellent. Look forward to the next.
Sounds great.
Thank you
All
very
right,
much, Chris.
signing off.
Have a
Thank
great
you.
day, everyone. Bye-bye.